This is the notes for section 3.6, perpendiculars and distance. We're going to first look at questions that look like this. It says construct a segment that represents the distance indicated. And what we're doing is going from the point that it gives you, C, to the line that it indicates, AB. And what you want to do is make sure that this line on your ruler is parallel or right on top of the segment AB, and you just bring the line down. On some sections, the line AB isn't long enough to go to the point D. So what you can do is use your ruler and have it extend. And I use the dashed line because I don't want to grade you on the dashed lines. I want to grade you on the solid lines. We're doing the same thing. We're going to have the ruler line up against the hash marks of the actual ruler so we can tell it's right on top of the line. Go to the D and bring your line straight down, and so you know that it's at 90 degrees. Okay, number 3. You're going to go to T and you're going to go to the segment RS. Since I have had plenty of practice, I kind of know that this won't be far enough. So I just take my ruler and extend that line. I make my ruler line up to the segment RS, and I go to the T. On number 4, we start from the point S and go to the segment PQ. So you just want to make sure that your ruler lines up right on that line so it can be perpendicular. On segment S, we're going to segment S and all the way to QR. I'm going to go ahead and extend it right on the line, and I'll make it dashed line. So again, what you want to do is make your ruler line up to the segment QR and then go to the S. And I didn't make it the right direction. We needed to go this way. There we go. Now this is 90 degrees. And the last one, we go from S to RT. Since I know it's going to drop down from that S, that's how I've got to extend that line. And you just saw me on number 5 that sometimes it works backwards, and you will see that it doesn't meet the segment. So you can draw it afterwards. All right, so remember the ruler has to be lined up with the line segment that it's asking for, RT, and you go from S all the way to the segment it indicates, and that's 90 degrees. On this next side, when we're looking for perpendicular bias distance, what we're going to do is that I'm going to ask you not to follow these instructions, but these. We're going to graph the information that they have first. 2 is we need to find slope and the perpendicular slope. And then 3, we're going to do the distance formula. And the distance formula is right here. So from your homework is where I'm going to do a couple of these problems just to make sure that you're okay. We're going to start with number 4. You can get some graph paper because we need to graph the sections. Make sure you put your name on your paper and your class period. That makes it easier for me to identify what class and whose it is, because once I have them printed, they go straight to the printer and I don't remember whose paper it was. And this is number 4. So we first graph the information. It says the line L contains the point 0, -2, and 6, 6. So we'll do that first. 0, -2. And then the point 6, 6. We're going to connect those two dots. And this is line L. The other coordinate they call P. P has the coordinate -1, 5. -1, 5. And we call this P. All right, so that was graphing. That was the first set of instructions I gave you. Now we need to figure out slope and the perpendicular slope. And we find the slope of the line. And what I want you to do is go from point to point. That would be going up 1, 2, 3, 4, 5, 6, 7, 8. So up 8. And then we have to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6 to the right, making it positive. You always want to reduce the fractions. This becomes 4/3. That means that our perpendicular slope is a -3/4 because you want to flip the fraction and flip the sign. Okay, so once you have this here, you need to find a P2. So I didn't write that down on your instructions, but you need to find a P2. Because you're going to use P2 and P1 for distance. What is P1? P1 is the one that they give you. P2 is the one you're about to find. How do you find it? You do the perpendicular distance. You're going to go down 3, 1, 2, 3, and to the right 4, 1, 2, 3, 4. If that is not enough to reach the line, just do it again until you reach the line that it has indicated. Okay, from here, you might want to get a separate sheet of paper. Because we have to find slope. So this is number 4. Please put the section, your name on it, and your class period. Just makes it easier for me to identify. Okay, we have number 4, and P was the point given. Let's read it from here, -1, 5. And P2 was the one that we found. So P1 and P2, which is 3, 2. Now you do the distance formula. The distance formula is the square root, and you do the x's first. Open parentheses 3 minus -1 squared plus. Then the y's 2 minus 5 squared. When you start doing order of operations to solve for these, inside the parentheses first, that gives you 4 squared plus -3 squared. Inside the parentheses, we have 16 plus 9, this will always be positive because you're doing -3 times -3, the square root of 25. So remember, I grade you on your work. Without your work, you can't get any credit, even if you give me the answer that it is 5, and without this, it's not enough. Okay. And then the other ones that I want to help you do is like problem number 10 and 11. So graph them, remember, and then you will find 2 points and do the distance formula. But let's do number 11. On number 11, I asked you to graph the information first. We have that first equation, y1, which is -5x. That means we start at the 0 and go down 5, 1, 2, 3, 4, 5, and to the right 1. So you will, that -5 means down and then to the right 1. We're going to connect these 2 dots. And in this section, I'm going to call them Y1, because they give you equations of lines. Now for L2. The problem with Y2, it says -5x plus 26, and we don't have enough space to graph. So what you can do is find another value. You want to go to x and y. What you can do is plug in an x value and get a y value, or you can use your calculator. Y equals. negative 5x plus 26. Then you hit that second button and graph, and it gives you a table of values. 4, 6, and 5, 1 are points on that graph, So we can plot those points. The other way that I was telling you is that you could plug it in. Negative 5 times 4 plus 26. Well, that becomes negative 20 plus 26 is a positive 6. And that's how you got the order pair 4, 6. Once you have those 2 points, you can plot them 4, 6 and 5, 1. So I asked you to graph the information given. The next step is to find slope. We already know slope. They gave it to us. Negative 5 over 1 is the slope given. So the perpendicular, you flip the fraction, 1/5, and you flip the sign, it was negative, so now this one's positive. From here, you can choose any point to be your P1, and you need to find P2. So you get to select the P1. I'm going to select this one, P1. And then I need to move the slope. That's up 1 to the right 5. 1, 2, 3, 4, 5. That makes this one P2. From here, now you get to do the distance formula. I'm going to write this as number 11. Your P1 was 0, 0. Your P2 was 5, 1. And we do the distance formula, the square root sign. The x is first, 5 minus 0 squared plus the y's, 1 minus 0 squared. That becomes 5 squared plus 1 squared. That's 25 plus 1, making the square root of 26 your answer.